Hi everyone. So today I'm going to go over lecture 9 on debugging, and so I'm going to start here on this screen with some notes. Then I'm going to transition over to Python, and we're going to do a couple examples. So this lecture is going to be all together, both the lecture part and the example part, because the lecture part really isn't very long, and so hopefully the whole video here won't be too long because of both of those pieces. All right, so the first part, this lecture part, I'm going to talk about three things. I'm going to start out talking about the programming cycle, and then I'm going to talk about different kinds of bugs. Then I'm going to talk about how to debug, some tips for debugging. Okay, so let me start out here. So that's sort of our outline for the day. Let me start out with our first part here, the programming cycle. Okay, so in the programming cycle, obviously this is a cycle. I'm going to write down the 4 different steps. So usually what you do is you sit down and you design a code. Okay, and the idea here is you're thinking, what should the code do? All right, and then once you design it, you actually write it. So you start to code. So this is the part where you write a piece of code. Okay, and then once you've written the code, you test it. Okay, and you want to, here you're checking if it works. Okay, and if your code's anything like mine, it doesn't work. All right, and so then you need to move from there over to the debug stage, which is where you fix the errors. Okay, and then you move back to the design, and you continue your way around. Okay, so my experience and the experience of many people who code is that the programming cycle works best when you do it often. So maybe the first tip, for programming, okay, is to write small pieces of code. Okay, so do this step as many times as you can. Okay, so you write small pieces of code, and in my experience in coding, if you haven't tested it, there's a bug. Even if you have tested it, there's probably a bug. But very much, if you've just designed something and coded it, there's probably a bug. It probably doesn't work. So you need to design, code, test, debug again and again, and try and break that into as small pieces as possible. Okay, so that's the first part there. So hopefully this resonates with your experience. We've been coding for a little bit now, so hopefully you've this resonates with you and you start to see this. Okay, the second thing I'm going to talk about are types of errors or bugs. Okay, so I'm going to talk about 3 types of errors or bugs. I'll talk about them each in detail first, and I'll try and compare and contrast them because sometimes people get a little confused. So the first are syntax errors. Okay, so a syntax error, this is an error of the obviously of the syntax. We've talked about that word a couple times. One way to think about it is like spelling, okay? Like a spelling error, or maybe a formatting error, okay? That's like analogy to writing. So think here, if I'm going to define let's do a while loop. So I might do while, and then I have some condition x is greater than 5, all right, and then I put down here, x plus equals 1, and I have x equals 0 up here. All right, this is going to give me a syntax error because if I didn't put the colon. Okay, so if I omit the colon, that'll be a syntax error. So it's kind of like a spelling problem, right? and these are the easiest errors to find. As a matter of fact, your code can't run without them. So the Python interpreter catches them. All right. So maybe you can think for a second. Think about an example of a time that you made a syntax error. Can you think of one? Maybe pause the video and say to yourself or your neighbor, what was a time that you made a syntax error? What's an example of something you've done? Example. Okay, that's my question for you. All right. The next one are execution errors. Oh, I'm drifting here. Sorry, my pad's moving around on me. Execution errors. Okay. An execution error is when the interpreter is okay with it. So the code starts to run, but it crashes somewhere. Okay. So code runs and then crashes. Okay. So something bad happened. Okay, so an example of this might be suppose that you have some loop. Okay, well maybe not even a loop. Suppose let me just give some silly examples. Suppose you divide by 0. Okay, you have some variable x over y. You make y equal to 0 somewhere. You divide by 0. That's going to cause your code to crash. Okay. Or suppose you have an array, okay, that's of length, 4, and you try and access it at the 5th element, but it's only length 4. Okay, it's gonna freak out at that. Okay, or any other kind of situation like this where you do something bad. All right, and these are less obvious than syntax errors, right? So they're sort of medium difficulty. Okay, to both find and fix, right? So you might not realize your variable was going to be 0, or you might not realize that your array was only going to be length 4 when you put a 5 in. All right, or you didn't realize you were going to put a 5 and you didn't, so there are situations like this that happen all the time. And again, this is an execution error. It causes your execution to stop. This was a syntax error. It was an error in your syntax. All right. So again, in this case, why don't you pause the video and think of an example? Think of a time that you've done this, that you've had an execution error, and identify it. Identify that example. All right. All right. So following that, we're to our last kind of bug. Okay. And our last bug is called a logical error. Okay. And this one is your code runs to completion. Okay. But it didn't do what you want. Okay. Suppose you wanted to make a plot, okay, and you wanted to plot y versus x. You wanted to see something like this. But instead, and you wanted to see this. But instead, your plot, you have x and y, and instead your plot looks like a bunch of garbage. Okay? You thought it would look like this. You know that the data looks like that, but you're getting this out. All right? That's a logical error. Somewhere along the way, you told the computer to do something, and you thought you told it right, but apparently you didn't. Okay? So this is the case where you think the computer is stupid. Okay? You think, I told it exactly what to do, and it didn't do it. Something's dumb here. All right? Or this is the quote I shared from the other day in class of an evil genie. right? A computer is like an evil genie. It does exactly what you tell it, not what you wanted it to do, all right? And these are the hardest bugs, the hardest bugs to find and fix. Okay, so why don't you, again, pause the video and think of an example of a bug that you've written that you've then found, right, of a logical error. Okay, so just think about these for a second before we move on and compare and contrast them. Usually people understand what a syntax error is. That one's the most straightforward. And an execution error makes sense, but students often, the question I most often get about this, rather, is what's the difference between a logical error and an execution error? And what I would say is the difference between a logical error and an execution error is in an execution error, your code crashes on you. Okay, so it goes to run and it doesn't finish. Your code doesn't complete, it crashes, there's an issue. All right, a logical error, your code runs, it just doesn't give you the output that you expected or that you wanted or that you needed, right? It gives you the wrong answer. Okay, so that's the difference between an execution error and a logical error. All right, so that's part 2. Now we're to our last part here, which is how do I fix bugs? Okay, and of course, if I knew the answer to how to fix every bug, I would be a billionaire and I wouldn't be teaching this class. But I do have some thoughts about how to methodically go about doing this. So my best answer for how to do this is something you already know. It's the scientific method. Okay, and this is actually one of the reasons why I think that programming is an extremely important skill for an engineer to learn, all right, or a scientist, or really anybody. It really, learning how to fix bugs is learning how to apply the scientific method. So what are the steps of the scientific method? All right, there is observation, all right, that's the first step. Then the second step is a hypothesis, okay, and then the third step is an experiment. All right, and then following the experiment, you come back up and you go back to observation, hypothesis, experiment. Again, okay, this is a loop, right? Or this is an iterative process. You do it again and again and again. So let's think about what this means. So observation, this is the part where you're testing your code, right? And you test it and you see, do I have one of these kinds of errors? Do I have an error? No error. That's a wahoo, right? I don't have a problem. But if yes, I do have an error, okay, I have to keep going down the list. Okay. Hypothesis. This is where you're trying to figure out what went wrong. What went wrong? Okay. You don't necessarily know. If you knew what went wrong, then you wouldn't have to have a hypothesis about it. This is a guess, right? This this is based on your intuition. Okay? Maybe there's something that you did in your code and you're not so sure about it, and so you go look at that part. Okay? You need to look for clues here. This is maybe the hardest part. This takes some inspiration, right? What is the thing that could be causing this, right? Once you have a hypothesis, then you need to isolate the thing that you're trying to do, okay, and test it, and test that hypothesis. So you don't want other things to vary. You want to have your hypothesis be, oh, there's this certain thing that I think is wrong, and I'm going to isolate and test that hypothesis, okay? So let's talk just for, I hope this process doesn't seem silly or trivial to you. It's not silly or trivial. It's actually very important and deep, and it takes faith and patience to do this process. Okay, both of those. Oh, I don't mean to cross them out. I mean to underline them. Okay, it takes faith Faith means that you believe that if you set up an experiment and do it and test it, that you'll have an observation that'll be relevant for your hypothesis. That can be hard to do. It takes patience to be able to do this through, all right? But if you have the faith and the patience to go through this method, the scientific method on your bugs, you will find them and you will fix them. I have personally spent weeks looking for single bugs, and it has taken me weeks to find them, but I have found them and fixed them, and it's been an important piece. And in doing science, I have worked on things that have taken me years. I've made mistakes that have taken me years, and eventually we have found them and fixed them. So this process, I can promise you from my personal experience, it really works to find your bugs. Okay. So let's just talk about some tips for this process, especially related to good hypotheses and experiments. Okay, how do you go about doing that? So let's think about, one place for a good hypothesis is to look at error messages. Okay, read the error message that you get out. A lot of times the error message will tell you what line the code crashed on. Let me separate that out. What line it crashed on, okay? It could tell you even the exact character that it crashed on. It might tell you, how it crashed. It might say things like, an array, or it might tell you that you had bad memory, or something, okay? Or divide by 0. I mean, these are all things that the code might tell you. And now you might think might have some execution error. You might say, oh, that's my issue. I get, a divide by 0. But that might be due to a logical error somewhere else that you need to fix, right? So sometimes these problems are go together, okay? Some good tests to do are to comment out, okay, lots of the code, so that you can isolate the problem, right? So if you think you have an area, suppose your error message tells you divide by 0, comment everything else out except the part that's divide by 0 and look at that. You can also look at the variables, look at the values of the variables. You can use print statements. In Spider, you have a variable explorer that's really nice to look at. Okay, it shows you what are those values. Okay, some other things to think about in hypotheses and experiments. So one thing is to check your assumptions. So what are you assuming? Okay, if you think about the things that you've assumed that are working, and then check those different assumptions. Another thing to do is go to the last line of code that worked. Oops, hit the eraser there. That worked. Okay, so what that means is, suppose you run a code, you run your code, it works fine to some, line 50, and then line 51 it starts breaking, right? Comment out everything, this is related to this guy up here. Comment out everything below line 50, and then go line by line and see what happens, okay? Maybe you're writing some function, and that function's breaking. Focus on that particular function and focus just on those pieces, okay? Another thing that's extremely valuable, all right, and I don't think enough people do this, is write out on paper, okay, what you think the code is doing. Okay, so for instance, that was like the worst way of writing doing of all time. Let's see, DOI, and oh man, I'm never going to get back to that line, doing. Okay, so suppose you have a for loop for I in range 5. This is just a silly trivial example, print I. Okay, so suppose you don't know, you have some bug associated with this. All right. Write out what you think this code should be printing. You say, okay, the first time through, I is 0. The second time, 1, 2, 3, 4. And suppose you really wanted it to have a 5. Okay, suppose that's what you think. You might write out 0, 1, 2, 3, 4, 5, and then run it, and you find that 5 never gets printed. It's only 4. All right, and then you would realize, oh, I think I have a problem. There's something I don't understand. You might then go look at the range and realize that you misunderstood a part of how the range worked, okay, about how ranges work in Python. All right, so all of these things are tips for either hypotheses or experiments that you can come up, okay? So I'm going to now turn my attention over to the activity over to Python, and I'm going to do something a little nervous. I have some codes that I wrote that have bugs in them. There's 2 of them, and I wrote these at least a year ago, maybe 2 years ago. So I don't, I'm debugging these cold for you. I'm going to show you my process, okay? And in doing this, I'm going to try really hard to state my observation, okay, my hypothesis, okay, and then the experiment that I am doing, okay, as I'm going along. And I'm going to be very explicit about this, and I don't want to take the time to write them down as I do them, but in your homework, you're going to have to write these down, okay? So in the homework for this time, you're going to have to write this down. And I find that if you do this and you practice this, you get better at debugging, okay? All right, so I'm going to put my pad down and give me 2 shakes to get over to this. Let's look at our code here. All right, so this is number 1, the example number 1. And this says, debug the following code, which is supposed to find the transpose of the matrix. Okay, so the first thing I'll do, I guess, is just try and run it. And it gives me an error. And the very first thing to notice is that I have a little sign here, spider's helping me out. And so I observe, my very first observation, before I even run it, actually, I saw this in the corner and it says, expect an indented block. Okay, so my hypothesis then is that this for loop right here, that there is, a syntax, or maybe you could think of it as a logical error, because I should be indented. So it's, really a syntax error here, and I need to be indented over to that point. Okay, so my test would be to press tab. My experiment would be to press tab to get that to move over and to see if that indented block goes away. Okay, so I do that, I press tab, hit save, and it does go away. Okay, so that's the first bug I noticed of all the bugs. All right, so now I run this. Okay, and the code doesn't run. I have an execution error. And I'm going to sort of step back and I'm going to try and read this code and see what's happening. So I have an array here. It's a 2-dimensional array. It's a 4x4. I can come over and print out A and see what it is. There it is right there. Okay, and A transpose is where I want to store the transpose. So what is a transpose? Remember, that's where I flip the rows and the columns, right? And so I want to make something that's, A ij and make it equal to A ji, right? I can pull this back up and write that down just to kind of make that obvious. I want to take A ij and I want to swap it for A ji, where remember that I here is the rows and j there is the columns, right? And I want to swap the rows and the columns around. So now that my j is my rows and my I are my columns. That's what I'm going to want to do. Oops, wrong thing. Okay, so I look at this and okay, so now let's run that again one more time. So now that I know what the code's supposed to do, I'm trying to make a 4x4 matrix, and I'm going to loop through each of the rows and columns and swap them. Okay, so the first thing here this says data type not understood. All right, and this is about A transpose. Okay, and I get that. All right, so my observation is that it's telling me data type not understood on that line because it says right here line 15. Right, I can even move this over a little more and we can see maybe that line 15. So line 15 right there. So the first thing I'm going to do then, I'm going to try a quick test of just typing out A transpose to see if it ever got even defined. And it's not even defined. Okay, so there's a problem in the way that I've called numpy zeros. It's never defining it. So if I'm not sure what to do, I think I know what the problem is, but just to say, if I'm not sure what to do, what I would do next is look up numpy zeros in Google and look up the documentation. Okay, and it shows me some examples of how to do this. It says the first argument has to be the shape. And I look down here, and in this third one, it shows me that the shape is actually in a tuple, right? It's already in parentheses. So I need to put my shape here in a tuple. So that's what I'm going to do. Hit save and run that. And now I got something to run, but I don't really care about the answer yet. I want to know if my A transpose got defined. So A transpose, and it did get defined. Okay, it got defined right there, and so I'm okay with that. Okay, now my code runs. I'm done with execution errors, and I'm ready to move on and see if I have the right answer. So now let me look and see what's going on here. So at the end, what I'm doing is I'm printing A transpose minus A dot T. Well, if you didn't know this, I know this because I've been doing Python for a while, but A dot T is actually NumPy's way of doing a transpose. So if I print A transpose minus A dot T at the end, that should be all zeros if I am doing the transpose right. Okay, that's a test I've built in to see if I'm doing the transpose right. And when I run it, I don't get all zeros. So I know I've done the transpose wrong. Right? So it looks like I need to fix something else. So what else am I going to fix? The first thing I notice is that on line 17 I have a 2, but I have a 4x4 matrix. So my hypothesis is that I should put a 4 here instead of a 2. So I'm going to put a 4 there, and then I'm going to rerun the code. And I rerun it, and I don't get the right answer. Okay? So now I think that 4 is right. That makes sense to me, so I'm going to persist, even though there was a 2 there before, and I'm not sure if I have the right answer. I think I'm going to go on. So this code is so short, there's relatively few other things I can do. But I look down here and see this line, and I'm thinking, this must be where the problem is, okay? And this seems a little weird, because I have a two-dimensional array. So I would have expected to have comma separated indices. I would expect to call, say, 0, 0 here. So what I can do too is I can look and say, what would I expect to do if I was going to swap these? If I was going to make A transpose equal to the AI. And I can come back and look at this here actually and say, I would expect that if I had A00, that would become A transpose 00, and I would expect A01 to become A10, and A02 to become A transpose 20. That's what it means to flip the rows and the columns. So here I'm writing it out. See, I'm using that strategy to write it out. So if I come back to Spider, what I'm doing here is I'm just saying A0 equals A transpose 0 when I and j is 0, and then I say A0 is equal to A1. That's doing something funky. So I think what I actually want to do is AJ comma I is equal to AI comma J. Okay, now that will do A00, and that will flip it here, 0, 0. Okay, A01, that will be A10. That's what I just wrote. That's what I just wrote down right here. So that makes a lot of sense to me. So I'm going to save that and run it. And I run it, and lo and behold, I was right. Okay, and so I have all zeros. Perfect. So I think I've debugged that code. Okay. Next one, debugging 2. So this one now says, in homework 8, we made a plot of an equation A of t, where A and t came from this. It says, debug the Python script below that makes a plot of this function. It says, and then it says, while doing this, write down each step. Okay, so I'm not going to write it down, but the first thing I'm going to do is kind of stare at this. So I import numpy, I define a bunch of constants. Then it looks like I define some variables, the number of steps I'm going to take, the a variable and the t variable, which are these arrays with zeros in them. Then I have a loop where I'm assigning these values, and then I make a plot. That seems okay to me. Let me see what happens. Okay, first thing it says is it has a n plus 1 can't assign to function call. All right, so my observation is that on line 34 that there's a bug, okay? And my hypothesis is it says, I can't assign to a function call. And I know that functions, when I define and call functions, I use parentheses. But for arrays, I need square brackets. So I think what's going on here is in this entire part, as I look at it, I've added parentheses instead of square brackets. So I need to change these all to square brackets. So I'm going to do this one, and I'm actually going to do all of them, because as I look down, A is an array up here, and every time I use A, I keep messing it up with the parentheses. And that's a mistake. And the same thing with T here. Okay, so this is the test I'm doing. I'm just changing this. I'm going to save it and run it and see what happens now. All right, so now this says index 101 is out of bounds for axis 0 with size 101. Okay, so this is telling me, so now I'm thinking, I'm overrunning the index of my array. So what's going on here? I'm a little confused, so I want to understand how many steps am I trying to make. So here I said n steps is 101, okay? And I'm thinking that's how many points are in here. And this n normally would go from 0 to 100. So let me just check that and make sure that that's working. Print n should go from 0 to 100. And it does. It counts 0 all the way up to 100. But on the 100th time, it's freaking out. And I think I see what's going on. So here's my hypothesis. Here I'm doing n plus 1. And this one is n, okay? And so this one is fine. It's going from 0 to 100, but this one is trying to step beyond that, okay? And so now I need to be a little careful because A at 0 is this initial condition that I need to have. So at t0, I need to have this be 0 and t be 0. I'm okay there. Okay, I'm okay there because I'm using zeros to initialize this. So what I can do instead is instead of starting at 0, and going to 101, I could start at, I could do two different things. I could start at 0 and go to n minus 1, okay? And then this will use the 0 for the first time, and that should solve my problem, okay? Because the very first time I come in, I'll do a1 and get a 0, which is fine, which is good, that's what I want. But it'll stop before the very last one on the 100 step, and it will assign 100 right there. Okay, oop, I wanted to put over in this box. Okay, so let me run that one. Let's see what happens. Oh, okay. So now it's giving me a new error, but I'm not ready to look at this error. I want to see what happened with my previous error. So t is defined 0 to 10. Good, that makes sense. A also is defined all the way, and things seem to be going fine there. Okay, so I declare that experiment good, and now I want to look at the next error. So I run it again to see, and it says name PLT not defined. Okay, PLT is what I use to make plots in. And now it's freaking out at me about all these things, and I look up at the top and I think, my hypothesis is that I haven't imported matplotlib. So I'm going to do that. That's my experiment, matplotlib.pyplot as PLT. Let me try that. And let me run another test. Okay, and I run a test, and lo and behold, now I get a plot. And it looks like I have A versus T, and I have a plot. And let's see. Let's go back and look at what it says from before. It says in homework 8, we made a plot of the equation, blah, 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 debug this script to make the plot of the function. Okay, so that was my objective, was to make the plot, and I found those errors. All right, so I think that's, just an example. So let's go back maybe real quick for 1 minute and think about what were the things I did. Okay, so what did I do to help find these bugs? I used the scientific method. I had an observation, I had a hypothesis, and then I ran an experiment, an isolated experiment. How did I generate my hypotheses? I looked at the error messages. I didn't get a chance to comment out lots of code to isolate it, but my codes weren't that big. Okay, I tried to look at values of the variables. I thought about what the assumptions were. I don't know if I had a great example of that. Okay, I went to the last line of code that worked. Even when I ran a thing new, I would go back and test and make sure that I had the thing done that I had before. Okay, and I even took an opportunity to write out on paper what I thought should happen with the transpose so that I could make sure I knew what was going on. Okay, so that is debugging in Python. Those are my tips, hard-won tips from many years of debugging that I'm trying to share with you. And I hope this is useful for you, and I wish you the best on your homework, and we'll talk to you next time.